Hello and welcome to another Solana tutorial. Today I have a very exciting topic for you because ptoken is live on mainnet. Finally! If you don't know what ptoken is, it's a more efficient, significantly more efficient implementation of the SBL token program, which is the most used program on Solana. And now they actually replaced it with ptoken on mainnet. Here's my first video on ptoken, if you want to get an introduction. And we're going to talk about why this is so exciting. And we're going to talk about what changes for you as a Solana developer. And mainly, we want to see it in action on mainnet. So, look at this. We are in epoch 971. And if we check the feature gates, we see SIMD266 efficient token program. Activation 972. That epoch hasn't started. But everybody on X was talking about how it already... I don't believe you. Let me do Solana feature status on mainnet. Scrolly. Last activated. ptok. Active since 971. So the current slot is the first slot where this feature is enabled. Let's see. So we have 971, not 972. 956, not 957. 953, not 954. 950. I see an off by one error here. That's, can I report a quick bug for the Explorer? That's all off by one. Just saying. But anyway, point is, in 971, which is the epoch in progress, this feature has become activated on mainnet, which means token transfers are now way more efficient on mainnet. And to see this in action, I'll need a wallet with Sol. Let's go. I just need some Sol. I need a main wallet. Let's go. Mates, main. I have a main. Or another one. Main. Which one do I like? Maybe this one. It's a capital A for Andy. My mainnet wallet. Let's go. There we go. Gotta switch to mainnet. Here we go, we're rich! We got 5 Sol, yo! We successfully on-ramped. And now we need a token. An actual token. I mean, I could create one myself. But I think I want to have a proper one. I haven't done this in so long. What's a nice token I could buy? Good old USDC, eh? Yes. Just to prove that the same token that we've been working with is now more efficient. I don't actually want to buy USDC, so I'm gonna use just a very small amount here. Just want to get $2. Connect. Are we ready? Let's go. Looks about right. And transaction confirmed. And now check this out. We are on mainnet for a change, because we usually work on devnet, because we're devs and also broke. But look at this mainnet transaction that is using a bunch of accounts because Jupiter, among which the token program and token 2022. Let's in lookup table. We'll see which one it actually uses. So first it's gotta wrap some Sol, which has CPIs to the token program. And once again, token program. And once again, token program. And once again, token program. And then once again, token program. And then we do the actual swap, which will CPI into, guess what? The token program. And then the token program. And then the token program. And one more time the token program until we do the actual swap. And use the token program twice until we're done. But then we still close the account with the token program. Oh, we're not done yet, because we then create another account using the token program, one more time the token program, and then the token program, again the token program, to finally close that account as well with the token program. So what I'm saying here is that token program comes up a bunch. You know, this is like a bunch of usages of the token program. So Fibo was like, we gotta make that more efficient. And they did. Because look at that. It's just 120, 130, 237, 179. And the total CU is 225,000, which for a swap with an aggregator isn't too bad. It's really not that much. I would love to compare that to how it was before the token program became efficient. But that might be a bit complicated to find out. The main program that was called was this one, the swap orchestrator. Can I somehow find like very old transactions for this? Or can I go to epoch 970 So there's the one before. And then check, I don't know, the last block there or whatever. And see if in that block we also used that program. The dflow aggregator, we certainly also used this one. There used to be a filter possibility here, no? Oh yeah, here. We see dflow aggregator. Oh wait, that is that program. That is the dflow. Here the swap orchestrator, that is actually the dflow aggregator v4. So obviously I'm gonna have a hard time finding an exact same transaction. Also those are failed. Let's see this one. This was the last transaction still using this program with the old token program implementation. What happened here? Create, and then it had a swap with destination, which, you know, isn't too different. And it again used the token program and the token program and the token program, but then a different swap, CLMM. So it's not a fair comparison. It also uses token 2022 program, so it seems to have a token with 2022 and one with a normal one. But yeah, also here the token program is used a lot. Token program. Look at this. And here, if you compare, the compute units used were higher. 1,000 something, 1,400, 6,000 for a transfer, 4,000, 4,000, 3,000, 4,000. So, you know, looks a bit different than how we had it here with the 100, 200, 37, and so on. And the funny thing is, the token program didn't change. Also here, that token program, that program that was called here, this token program transfer, the program is the token program. This one, token keg. This address did not change. This is also the same one that here, that token program, here, that token program, same one, token keg. So they didn't deploy a new token program, but they swapped out the implementation of token keg, which is the only sensible way to do this, because then automatically all of the token program instructions become more efficient without all the apps having to change to a different token program, which nobody would do, or just a few, and then it's by far not the effect that you want to have. Because with the token program instructions needing so much fewer compute units, we suddenly have more throughput on the chain, simply because blocks, they're limited by how many compute each block can have, and so by needing fewer CUs, we can put more in a block. Therefore, have a higher throughput. I read like 13% improvement. Wait, answer, ptoken. Let's see, here. P-token. We're measuring roughly 12 to 13% block space recovery from P-token switch alone. And then we can have further gains with batch. Batch and withdraw access lamports are two new instructions that the token program now supports. Watch my video on the new features of the token program that I made a while back when I still had to deploy that program myself. Now it's just the token program. Now it's just token keg, and token keg suddenly has new functionality as well. Not just that it's more efficient, it also has two new instructions. And one person, let me find that here, over 100,000 Sol is stranded on SBL Mint accounts. This guy made a site where you can check the tokens for how much Sol is on them. And there's one token that has 6,300 Sol stuck on it. Let's check that. That's the mint address. It's a mint. It doesn't show me because... Oh, I can do raw? Yeah. Love this feature. Wow. Did they implement that because I requested it? I love this. It's a great feature. It lets me make this a regular account and see how much Sol is on there. And yes, look, 6,000 Sol. So why did that happen? Because people accidentally sent Sol there, or there was a bug in some program, or it was a deliberate scam. We don't know. Oh, they also show raw data now. What? I love the Explorer. It's getting better and better. Look, love that. You know, I once made a video on features of the Explorer. They listened to me. I love this. Cool stuff. Okay, anyway, getting distracted. Point is, there's a bunch of Sol on that mint. And if it had a mint authority, which it doesn't have, then it could be recovered through the mint authority. Now, it can still be recovered if you have the private key for this address. So the people who created the tokens can recover the sol that is stuck on the token mint accounts. Token 2022 has that already, and other programs too, but it wasn't possible with Token Keg. Token Keg, if sol is stuck on a mint account, I always had to tell people, no way of getting it back. Now, there is a way of getting it back, however, usually not for the ones who lost the sol, but for the ones who created the token, which is a bit unfair. Like, honestly, in most cases, I probably would prefer if the sol was forever stuck on the token mint than for the scammers who created the token, or maybe the legit people who created the token, to get that sol out. I don't know. But like, whatever. That feature exists now. If you created a token and you or somebody you know accidentally sent sol to the mint account, you can now recover it, either with a token keypair or with the mint authority. Well, actually, I think first you would need the mint authority if it still exists, and then the keypair. I would still need to read up on that or check. I mean, we could check it quickly ourselves. It's not like we can't create a token. So I'm gonna get myself another wallet real quick. ptok, and then mint. There we go. We have a 2 in a row. Okay, so Solana config set the key to this JSON, and we go to mainnet. Oops. Go. And then double check the address, and because I don't want to work with a wallet that has 5 sol, I'm just gonna send 0.1 sol to this address. Let's go. Cool. Nice. But also, speaking of sending, I want to send $1 to the same address. Let's go. Transaction confirmed. Just to see how much compute that takes now. I'm setting the limit to 16K, and even with creating the account, so associated token program, creating the account, the actual transfer here is just 105 compute units. So in total, we're less than 14K compute units. And if I don't need to create the token account, let me send the rest, then just the transfer is just 400 compute units. Why? Because I need 150 for compute budget, 150 for compute budget again, and then just 105 for the actual transfer. So the transfer costs me fewer compute units than setting the compute limit and the compute unit price. Fun times with the token program. And that is Token Keg. You see it over there. I love this. It's pretty fun. Okay, but where were we? We wanted to create a token ourselves, right? So SBL token, create token, a regular 9 decimal token keg token, nothing special. The only thing special I'll do is to use the mint as a key pair, that we have a nice mint address. So that's now my token. This is a regular token owned by the token program. See, assigned program ID is the regular token program. I love this. I love that we have this here now. Raw bytes, awesome. And the balance, that's just 0.001 for sol. That's minimum for rent exemption for, I don't know, 85 bytes or whatever, 82 bytes. And if you don't know how Solana works, you might mess stuff up and accidentally transfer sol to a mint address. Should I send 1 sol? That's risky. I mean, everything in me does not want to do this. Also, Solflare I think will warn me if I paste a mint address. It even says incorrect Solana address. The selected recipient is a token account that doesn't match the selected token. It's not a regular one. It doesn't even let me send it because, you know, the wallets are being careful because so many people lost funds by sending sol to a mint account. Okay, so I can't do this with Solflare anyway. Could do it manually, but I don't have that much sol. How much do I have left? 0.05. I mean, there's no fun in that. I want to go high risk. I want to send 1 sol. So I'm gonna use the key pair from my main wallet. Main wallet, let's go. You should really not do this. Oops! I sent 1 sol to a freaking mint account? It has 1 sol now. No, that sol is lost forever. Or is it? I hope not. Because this is mainnet. This is real money, guys. I'm risking my real... Because I'm convinced that I can get that off. Right? Usually, with Token Keg, this 1 sol would be lost. But we have that new function with the withdrawal that we just gotta get to work. And so, let's see if that feature is also already available in the Solana program for the kit. So let's write a program. You know, our usual stuff. Good. Add some Solana kit and Solana program token. Great. We added the dependencies we need such that that should work. We don't need the system program. We load our keypair. That's the one that we created the mint with, and that is also the mint authority here. And then we just do the usual transaction sending and the instruction. Now, this is gonna be interesting. I'll import from Solana program token, and we will hope that there is a get withdraw access lamports. Yes, they've added it to Solana program token because that's now an instruction on the token program, the regular token keg token program. So all I gotta do is get a withdraw access lamports instruction, and what it needs is the authority, the destination, and the source. Easy. Authority, here the signer that I have from my keypair. The destination, I will just withdraw it to my address, and the source, that's the mint. So that's this address, and it will withdraw all access lamports. I don't have to say how many I want to withdraw. It will just withdraw all of them that are not required for rent. And like that, I should be able to get my sol from mainnet. Let's see. I haven't done anything on mainnet in a while. Oh, you want to be a module? Yes. Try again. And look at this. We sent a transaction where the mint had -1. One. Wow. Was there a bit too much rent on there? Where does that one come from? Did I send more there? Hold on. Because when I sent the... Oh, wait. What happened here? That's where it comes from. But what happened here? Oh, is that such a spamming attack? The maybe... Oh, yeah. I see. Okay. Watch my video on dusting attacks. Sometimes addresses spam other addresses that just received some funds with an address that starts similar, such that I would accidentally send the one sol back to here. And oh man, I could have fallen for this. But my real transfer was here, where I sent the one sol. Okay, that explains why it's 1 and a little bit. Hey, look, I made... How many lamports is that? 10,000 lamports. That's like 2 transaction fees. Amazing. Anyway, so cool. Thanks for paying for my transaction fee here. And I got that one sol back. It wasn't actually mine. It belonged to, you know, that guy, which address I should not copy from here. If I would be nice, then I would send that sol back to him, but I should copy the wallet address from here and not from the Explorer. Be careful with that. And now that I have one sol, I could be nice and transfer the one sol back to the guy who sent it to me, or who sent it accidentally onto the mint account, my main wallet. Cool, so that was super easy to do that with the kit. It has this get withdraw access lamports instruction, and it will also have a get batch instruction. While we're here, let's do a batch transfer just to see what that takes. It takes an array of batchable instruction. Okay, so you have an array and a batchable instruction. Nope, that's probably not how we should do it. What is a batch instruction? Where the program is a token program and batchable is true, or non-batchable is true for this batch instruction. Can't batch batches, and all the others, I guess, that is not a batch instruction will be batchable then. So for instance, I could do a get transfer checked instruction. So what are we even transferring? SBL token accounts. We have $2. And since we are the mint authority, let's also SBL token create account for this mint, and then actually mint, I don't know, 100 tokens. There we go. And then I can transfer them. The authority is my signer. The mint, I'm gonna save it as this address. The source will be my token account. I could also derive this, or I just hard code it because I know where it is. Here you go. Amount. Let's just send one token. I know we have 9 decimals. 9. And destination, well, we still need a recipient. And we don't copy it from here. We copy it from here. However, that is the main wallet. I would need to derive and create the ATA. I'm gonna do it from here real quick. Create account for this mint, for this owner with this fee pair. Ha! 3. So that's the recipient token account. I'm also gonna hard code this. There you go. And that's a batchable instruction, which is why I can get a batch instruction and put the transfer checked instruction in here. Nice. But a batch instruction is pretty useless if you just do one thing. So let's do another thing and do another transfer also from my signer, and this time we are going to send some USDC. So I'm gonna use this as the mint decimals, and no, it's got 6 decimals. I could read that, but whatever. Amount, what am I gonna send? $1. And destination, now here I'm gonna actually derive find associated token PDA for, I should save this as USDC mint, then I can reuse that here. Owner will be my recipient and token program will be the token program address. And then I will await this, and there you go. Just need the address, not the bump. And source will be my USDC. I could look it up with -v, so this one would be the account. I could hard code that or also find it from my signer address. There you go. That's a clean way to do it without hard coding. Okay, that way I have, oh, we're not happy. Still missing something? Oh, yeah, a comma. There we go. So we have 2 transfer checked instructions inside this batch instruction, which will make it just one batched transfer. It's just one instruction to the token program, but really it's doing as much as 2 instructions. And I could add more in here, right? You think that's just gonna work? I guess so, why not? Because all the token accounts should already be created. Let's run this batch transfer. Yes, look at that. And if we have a look at this transaction, we see a bunch of accounts and we see the token balance changes. Look, I sent 1 USDC and 1 of my mint tokens. And look, that instruction, it's 1 instruction to the token program. It's a batch of 2 instructions, a transfer checked and a transfer checked. Nice. I could look at that raw and see how the accounts and instruction data looks. But you know, the details of that we discussed in the video when we talked about that. And all of that just took 449 compute units. Now you might ask yourself, but Andy, if I would have just used 2 transfer instructions without the batch, it would have also worked to have 2 individual transfers, and it would have overall taken me fewer compute units. So why would anybody do the batch? Great observation. Person who is pretending to be a different person than me, but who is actually me still. Obviously on top level you don't need to do this because the token program is already optimized for that, for those instructions to be as efficient as possible. That only makes sense if your program is CPIing into the token program, because the CPI is what's expensive. Because doing a cross-program invocation, you gotta do like a context switch or whatever. I don't know the details of the validator implementation, but doing CPIs comes at a cost, and that's reflected in the CU usage as well. So if I had a program that CPIs into the token program twice, then it would make sense to change my program to just do 1 CPI but have it a batched instruction. Like we saw in the very beginning here for the swap, when we're doing a lot of stuff with the token program, or here we're again twice using the token program, it would make sense to change that to a batch instruction. And maybe I'll analyze in a future video how much more efficient it is and what instructions are possible as batch instructions and how many instructions you can do into one single batch instruction. I'm sure there's limitations and whatever, but I don't want to blow up this video. So this is good enough for me today. We saw how we can do 2 transfers in 1 token program instruction using this batch instruction, which is a new feature of the token program. Also, we see here down in the logs, the token program stopped doing logs. When we had a look at the transaction from the previous epoch, the token program always said instruction transfer, instruction close account, which is nice if you see it down here. Because then if it just looks like this, then you're like, well, what's happening here? I gotta scroll up. What transaction was that? That was here. Okay, it's not as easy to match what the program logs, say, to the instruction list anymore, but therefore it's just much more efficient. You don't want to do logs, and also especially here when the associated token program calls the initialize immutable owner, it always printed that message, which just always wastes compute units. We know this. You don't need to tell us anymore. So all of those messages are out of the production, out of the deployed program, the P token program that has replaced the SBL token program at the same address, token keg. So it's not doing this anymore. It's still returning. When you do a return, obviously the token program, if you call the get data size, then it obviously still does that, but it does not log anything anymore. No messages, because we want to be compute efficient. So to finally wrap this up, if you're a dev, I'm gonna get bigger. If you're a Solana developer, you don't need to change anything. This upgrade will automatically make your program more efficient if you're using the token program, because the token program became more efficient. And you don't need to change anything. The only thing where you might want to change it is if you hard-coded how much compute units you expect the program to take, because that number got decreased. But I don't think anybody really does that. You usually simulate for that. And another thing, if for some reason you were relying on those messages, if you really like parse the log output and you're looking for those kind of things, transfer checked or whatever, which already is not the best way to do things. Definitely not, because logs get truncated. But in case you did, that will not work anymore. It's not good practice anyway, so I don't think anybody does that. But that has changed, so the logs have changed. But otherwise, the token program is exactly the same as token keg was, so in the SBL implementation, plus the new instructions, the batch and the withdrawal. And the batch, depending on what your program does, might make it even more efficient if you were using batch instructions instead of several token program instructions. But that I might put into another video. We'll talk about that next. And here's another video that you can watch. Like this if you like P token, or my face, or both. And subscribe if you haven't done that yet. And I will see you in the next video. Try out P token. Man, it's so cool. I mean, try out. You are using P token if you're working with tokens on Solana, unless you exclusively use the Token 2022 program. But yeah, we saw a bunch of things. We did the batch transfer, and we even managed to recover a sol from a mint account. And all of that on Solana mainnet. P token. Pretty cool stuff. I like it. And I'm so happy that it's finally on mainnet. What else did I want to say? Feels like I wasn't done. Okay, I have sent another 0.05 sol back to the mint because I want to try something else. What if the mint doesn't have a mint authority anymore? So SBL token authorize this mint, the mint disable. So disable the mint authority, new mint is now disabled. Okay, so what has changed now, the mint authority from this became this. We don't have a mint authority anymore. But we still have too much sol on that mint account. If there's no more mint authority, then you can still claim the access lamports with the mint keypair. So this is not gonna work anymore. The withdraw from mint will now not work because custom program error 0xf account does not support specified authority type. Because the authority now doesn't need to be the mint authority anymore because there is no mint authority, but it will need to be the mint keypair, which I have also stored in here. And if I put the mint keypair as my authority, then that should work. There we go. So now I had to sign with my mint keypair, and then it lets me remove the access lamports and get them out. Nice. I should have checked if I can also do that before I remove the mint authority, but I don't think so. I think as long as there's a mint authority, you need to sign with the mint authority. However, I didn't check that. You can check that as homework. Cool. Well then, see you in the next video. We'll talk about more of the batch instructions.